All right, guys. So now we're going to think about the integral as being an accumulator. This is a very important concept. So we are used to being given a function and being able to interpret its derivative. So if I told you that W of t represents your weight at time t, if you're trying to gain weight for wrestling or lose weight to look better at the prom or whatever it is, then your weight will be changing. And so W prime of t represents the rate at which your rate is changing at time t. It's the instantaneous rate of change. So G of t could be the total number of gators in the Florida Everglades at time t. Maybe measured, maybe they do an annual, try to keep track of the gator population annually. And then G prime of t would be the rate at which the gator population is changing. It might be increasing or decreasing at time t. V of t, of course, we're used to being velocity, and the rate at which velocity changes, V prime of t, is called acceleration, and we list it as A of t. So these are just a few of our things that we might deal with, functions, and we might look at their rates of change. Now let's go backward. So we're going to assume that you understood that W of t is your weight. W prime of t is the rate at which your weight is changing. Okay? So if I apply the fundamental theorem of calculus to this integral, then the integral of W prime of t dt using the fundamental theorem of calculus means take the antiderivative of W prime, which would be W of t, and I know I've got to take that from B to A, so W of B minus W of A. Now, think about what you've got. W of B means your rate at time B. W of A means your rate at time A. So if you subtract, you're getting a difference in your weights from time A to time B. So if you're trying to gain weight, for instance, to I don't know, gain weight for football or something like that, because I think wrestlers actually want to lose weight a lot of times. But if you're trying to gain weight, W of B minus W of A would represent the weight you've accumulated from time A to time B. Okay? So accumulating a rate of change, integrating a rate of change gives you accumulated change, an amount of change. So the same thing, if G of t represents the total number of gators, G prime of t represents the rate at which that gator population is changing. If I integrate G prime of t, the antiderivative of G prime is G. Then I go from G of B to G of A, and I subtract. So I would be calculating the gator population at time B, the gator population at time A, and getting the difference in the two gator populations. So that would let me know how many gators I've added to the population or how many gators I've subtracted from the population. So it would be accumulated gators, for lack of a better way to put it. Okay? So whenever I integrate a rate of change, I get an amount of change. So G prime is a rate. G of B minus G of A is an amount. Okay? That's really important. Amounts you never say like miles per hour. It would just be miles. So we got to make sure that we know what units to apply when you're asked to interpret an answer in the context of a problem. So if V of t is velocity and V prime of t is acceleration, if I take the antiderivative of acceleration, I get velocity. And so what I wind up getting is the difference between my velocity at time B and my velocity at time A. So if I'm going 55 miles per hour at time B and I'm going 45 miles per hour at time A, then I've gained 10 miles per hour. Okay? So the overall increase in velocity is 10. That's the amount or the accumulated velocity. So again, we want to make sure that you understand that when you integrate a rate of change, you accumulate an amount of change. So we've not already done this one on the first slide, but now I'm starting to branch out a little bit. If S of t stands for the position of a particle at time t as it travels left and right on a horizontal axis or up and down on a vertical axis, then S prime of t is the rate at which position changes, and we know that we can say that's v of t. So if I integrate velocity, I get position, and this would give me the accumulated position, the difference between my position at time B and my position at time A. We call accumulated position displacement. So displacement is just the difference in where you were and where you are now. It's not necessarily that how far you've traveled, which we'll talk about in the next video clip. But you've heard position from, or displacement from when we talked about particle motion in the derivatives half of this class. So we're going to circle back to those ideas. So we know that in general, if you integrate f prime, you get f of x from b to a, and that's f of b minus f of a. So again, if you accumulate or if you integrate f prime of x, you're integrating a rate of change, and you wind up getting an amount of change. That's very important. So that's the accumulated amount. So I'm going to call that just accumulation. Now, look, if I want to solve this equation for f of b, I simply add f of a to the left-hand side, or I add it to the side with the integral. So f of b equals f of a plus this integral is telling me that f of b, which is my new amount, equals f of a, which was my initial amount, plus the accumulated amount of change. So I might say, well, my new position is equal to my starting position plus my displacement. That's a common question on these. Or my new velocity is equal to whatever velocity I started at plus my accumulated velocity. So if I started at 45 miles per hour and I accumulated 10 miles per hour, then my final velocity is 55 miles per hour. This basic construct will get us out of a whole lot of jams if we always come back to this simple idea. So traffic flow, hey, we just did this problem. We did, but I asked you another couple of questions on it, or maybe one question, maybe part C or something. But now we're going to do part A. So traffic flow is defined as the rate at which cars pass through an intersection. We already know that. Big F is in cars per minute. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? Okay, I want the amount of cars that go through the intersection. Guys, all I have to do is integrate the rate at which cars go through the intersection. So it says over the 30-minute period, so going from 0 minutes to 30 minutes of f of t dt. Now, this is number 1 on the free response, which means it's a calculator problem. So guys, the minute you set up the integral, you are telling the reader what you're thinking and what you're doing on your calculator. You don't need to do anything else other than to do it on your calculator. So on a calculator problem, set it up and then go to the calculator. I'm hoping I still have f of t in there. I believe I do, don't I? 82 plus 4 sine t over 2. Oh, good. That makes life easy. So I'm going to do second quit, and I'm going to say I'm going to math, choice 9, function integrate. I'm going from 0 minutes to 30 minutes on my limits of integration. I'm going to integrate what I've already inserted in y sub 1. And now I'm integrating with respect to x. I always will in Calc 1. Hit enter. So 2,474.0775. So let's interpret what that means. 2,474.0775. Now, we went from a rate of cars per minute to an amount of cars. Okay? So I'm going to interpret that as meaning during that 30-minute period, roughly 2,474 cars went through the intersection total. Okay? Not so bad, huh? All right, so this is a problem that was on the maybe 2018 exam, and I think I've mentioned this to you all. There are a lot of funny answers because it asked about the number of people that were entering a line for an escalator. And this is the one where some people were coming out with answers like 14 billion and weren't considering that that would be like the population of a country, not the number of people that are in line for an escalator. So I think that I've mentioned to you that we were tickled by some of the answers because generally the answers will make sense. So how many people enter the line for the escalator during the time interval from 0 to 300? So R of t is measured in people per second, and t is measured in seconds. So 0 to 300 would be 300 total seconds. So if you divide that by 60 seconds, you're talking about the number of people that get in line for an escalator during a 5-minute period. And I'm fairly certain it won't be like in the billions. Unless it's very, very crowded at Macy's during the holidays in New York or something like that. I don't know. So all you're doing is you want, if an amount of people that get in line, then integrate the rate at which people get in line. So you just have to say integrate from 0 to 300 r of t dt. Now do not write down r of t, guys. Don't take a chance that you write it down wrong, because if you write r of t wrong, you could miss the setup for the problem. So just use r of t. Use what they give you. But now we do need to put r of t in our calculator. So I'm going to enter 44. What we think must have happened as people were putting these in their calculators, somehow or another, they may have gotten their exponents in the wrong place or something like that. So be really careful when we go to putting it in. I'm writing it down so that when I change the screen I can still see it. So here we go to the calculator. So I'm going to clear this screen. I'll come back to it. I'm going to my y equals screen. I'm going to clear out what was there already. So let's see here. It's 44 times t over 100. So x over 100, close parentheses, quantity cubed. And then make sure you hit your right arrow key, because who knows, that might have been the issue. Times 1 minus, and I'm going to put the t over 300 in its own set of parentheses. So x over 300, close parentheses once, close them again, because all of that 1 minus x over 300 needs to be to the 7th power. Enter. All right, so now I'm ready to go to my home screen and integrate that amount. So I'm going to go to Math, Function Integrate. I believe we were going from 0 seconds to 300 seconds, if I remember correctly. I'm going to plug in y sub 1 here. Now, most of the time you will wind up working with the same y sub 1 multiple times. So it's better to just enter it once and be really careful the one time. If you only work with it one time, you could plug it in actually here on your home screen. But if you have to work with it multiple times, you're faster if you'll plug it in your y equals screen and then just use your calculator commands. So 270, that makes a little more sense than 14 billion, I think, for the number of people that get onto the elevator. Or escalator, I guess it is. So I'm going to say 270 people enter the line. And they always want you to attach times to it. So from t equals 0 to t equals 300 seconds. So you always kind of have to repeat, if they want you to interpret, you always have to repeat the time, either interval of time or specific time that they give you. All right, so that's all we're going to do on that problem, because I want you to realize these aren't so bad. All right, one more video, guys. That's it.